Okay, guys, we'll get started. So today's the Numpy discussion, but before we get into it, just some announcements. Um, the homework is due on Wednesday, but as usual, we have the 3-week grace period. And then also, we'll be talking about final projects next week. So just keep that in mind. They'll mainly be like solo projects, but you could have a partner if you'd like to. More details coming soon. Okay, so if you haven't already, please pull up the discussion so we can get started. There are 4 questions today. I think we'll only get to 3, hopefully. But yeah, a lot of these are similar to how you should approach homework questions for NumPy, so we'll get into it. So our first one, we want to make a function that takes in an array, and then we want to reshape the array so that it becomes a square matrix. And then finally, we reverse the multi-dimensional array and return it. And then an extra thought is to think about what kinds of arrays could be inputted into your function and how you want your function to react to those kinds of inputs. Okay, so if we look at the function, we have a doc test. So it's not super necessary to understand what this does, but basically this allows you to, whenever you want to make something random, like a random array, if you input this number, it'll output the same array every single time. So this one basically makes a random array, and this was the output. And then when I called the function onto this array, it reversed it and made it into a 3x3 matrix. So let's first analyze what the length of this array is. If you look up here, I specify that it's a size 9. And that's why we can make it into a square matrix, basically, because 9 is a perfect square. So you have 3 columns and 3 rows. And then also we can tell that it's reversed because it starts from here. So 6, 1, 2, then 5, 9, 4, then 1, 5, 2. So that's how we know it's reversed. Okay. So these cases are optional. Let's not get into it for right now. Let's try to address this test case first. So does anyone have any ideas on where to start for this one? Or actually, take like 2 minutes to think about the problem and maybe try some things out. And then I'll see if anybody has any ideas. Because we're reversing the array. Because we're reversing the array.
Yeah, but like, why can't it? Have you said put it in reverse term?
You never heard of it? Oh my god. Let me see if I can find it. It's like a meme. It's like this guy's on a wheelchair and then a bunch of fireworks are going off and they're like, put it in reverse because like I guess it malfunctioned and he didn't put it in reverse. Like nothing bad happened to him, but
That's so good.
yeah. Okay, does anyone have any ideas on where to start?
Also, remember you can use Google.
Mm-hmm.
Google is your friend on this.
You are encouraged to use Google. Okay. uh, If not, that's okay. Let's think about what the question is asking. So we want to reshape the array into a square matrix and then reverse the array. So let's talk about the reshape part. Does anyone, how about somebody look up a function that can reshape an array? So like look up how to reshape an array Python and tell me what it says.
Oh, I got matrix equals, you want me to say it out loud?
Yeah.
Matrix equals np dot array parentheses, I guess the name of that array, dot reshape parentheses size comma size.
Okay. So it looks like we can use the reshape function. So np dot reshape. Okay. That's our first step. But oh, and then let's look at the not my, so let's look up this function. Clearly I've looked this up before. If you see like Numpy here, this is the official documentation. This is really useful website. Let me get rid of these. Because it'll show you what parameters it takes in, and then also it'll give you an example. So if we look at this one, actually let's look at this. So we have it makes an array with the numbers 0 through 5, and then it reshapes it into a 3x2 matrix. So we have 3 rows and 2 columns. Rows, columns. So we're gonna basically use it like this, except this way might be a little bit easier. So we pass in our matrix or array, and then we give our new shape. So originally it was 3x2, but then we're able to shape it into a 2x3 here. So we'll do the same thing here. So we want to reshape our array, and then it's called R. Okay, but how do we know what our dimensions are? Yeah,
It's a 3x3 square, right?
well, only in this example, yes. Our passed in array is a single dimension. Like this.
Okay.
And we want to reshape it into a square matrix.
Could you say the size and the square root of the size?
Yes,
For each term?
yes, exactly. So if you notice here, this is of size 9. The square root of that is 3. So that's why it's a 3x3 matrix. So let's input that. So how do we find the size of the array?
So that we're gonna make.
Of our given array.
And then just like LPN.
Yeah, we use the len function. So len of r, and then we take it to the 1/2 power. Also make sure to pass it in as a tuple, otherwise you'll get an error. Did you have a question?
So for, if you have, like, if this was going to be used on an array that wasn't a perfect square, it just wouldn't work, right? Because it would not be able to square root and function into a number that is immutable.
Yeah, and that's why these cases are here, to see like what you should do in that case. But for right now, we'll just try and we'll address this case first.
Okay.
So then let's call this like new array. Okay, so we have the reshape part. Now we need to do the reverse part. Does anyone remember how we reversed a list? Yeah. Yes. So we would do the same thing with our array, even though it's multidimensional, except it's a little bit different. There it is. Oh. Does anyone remember the syntax for that? Yeah.
Isn't it like colon, -1?
Yes. Okay, can we just stop right here? Would this work? Anyone have any guesses? Yeah. We don't need commas here, because then it would be, the commas kind of indicate rows and columns.
Oh.
Yeah. Any other ideas? So in this case, this would work if we had a one-dimensional array, but we reshaped our array into a 2D array. So we have to do this for both the rows and the columns. I think if you had just left it a single one, it would reverse in like one dimension. I'm not 100% sure.
I think it just reverses the rows.
Yeah, that's what I was thinking. Okay, so let's try this. Yes, okay, and then, oh, I meant to do the dog test. It's gonna give a bunch of errors. Okay. Okay. It's all the old ones, all the later ones. Oh, okay. First R. I think it failed. Okay, it failed that one. That's fine.
It's because
Yeah, it's because of the second one. Yeah. Oh, shoot. Yeah, you're right.
The length of the array square rooted is.
Yeah, it's gonna be a float, even if it's perfect. Yeah, so we need to turn these into ints, because you can only pass in integers for your size. And even though it's a perfect square, it will make it a float. So it would be like 3.0 instead of 3.
That's because you're using the power to a rational number, or
No, I think it would do the same thing even if you use the square root function.
Most square root functions in Python are going to return a float because more often than not, we have decimal points in our square roots.
and you want it to be the same no matter what.
It's just that reshaping since integers, not floats, because you can't have 0.5 of an dimension.
Yeah.
Does that make sense?
That makes sense.
Is there a way to test the dog test just a function? Because it's gonna test every single function.
Yeah, try,
It's probably some, I had this problem before, it's some syntax, but this is correct. Yeah, so it worked in this case, even though it says failed, it's because of some syntax in the dog test, but we got the expected output. So instead of going over the optional cases right now, I actually want you guys to think about them at home. See what would happen if what you want your function to do if you got an array with like the wrong size. So in this case, I tell you to say like, oh, it's like not supported, please try again. But you can always like think of what else you could do in that case. Yeah.
Would it be another way to also make it square, even though that's not going to happen? Or are you
Well-
just saying, because it wouldn't be able to be square, right?
Yeah. It won't be, you can't make it square unless the length has a perfect square. But something you could do is like add numbers to the end of it. So like maybe for example, if this was some kind of like length of data and you wanted to reshape it to a square matrix, you could probably like add the mean to the end of the array so that would be a perfect length. Maybe like some kind of, maybe you're doing some like data science or statistical analysis. Like that's like something you could do. Like this is just like an example. There's so many different things you could do. None of them are right or wrong.
What is that? The second one then?
This one?
Yeah.
So we're passing in the size as a tuple. So it'll be the rows and columns.
Okay.
So we need both of these to be ints.
So it's like part of the shape of your.
Yes. Yes.
Yeah, so if you ever call dot shape on anything, you'll notice that the output is always a tuple of integers. And that's on purpose. Because I think it's easier to check if something is a float than it is to check if that decimal point is a 0. So like instead of checking, oh, it's 3.0, that's fine. It says no floats whatsoever in my size.
Okay. Any other questions on this problem before we move on? Okay. Let's go to problem 2. Okay, you're given an array and you want to return its sorted version with only the unique elements in it. And then we want to also return the counts for each value. And I say there's an easy way and a hard way. Hard way meaning like loops, easy way meaning look it up. So if we look at the doc test, we have this array. It's like 10, 2, 5, 10, 8, 2, 8, 9. And when we pass it into our function, it should output the array sorted with only the unique values and then the number of counts. So if you look at 2, it is in this array 2 times. If we look at 5, it's in it once. 8 appears twice. 9 appears once. And then 10 also appears twice. Okay, so I want you guys to take the time to look up how to do this because there is a very nice function that does this for you. So we like how to find the unique elements in an array, Numpy, Python. And then try it out for yourself. Okay, did anyone find anything on their Google search that they'd like to share?
Anything you wanna share tonight? You said,
Set? Like in what context?
I don't know, it says bring length and then set in the new array.
Like what?
It's length, set, and the name of the array.
Ooh, okay. Let's see. Oh, how do I bring the terminal to make a new term? Guys, this thing is too tall for me. I'm like on my tippy toes. You can? I was wondering why like this is so much taller than last time. Actually, what might be easier is this and me. Oh, okay. And then I'm gonna define this outside. Okay. I can just run this. Okay, so this outputted 5.
And it's supposed to, right? Cause it's the only one that didn't get repeated.
No, a 9 also. 1, 2, 3, 4. Oh, I think it's telling this says the number of unique elements.
Oh, right.
It's because if you make a set out of an array or list, it only takes in the unique elements. A set is another data structure. So that's like on the right track because it gave us the number of unique elements. Did anyone find anything else? Yeah.
You could use count, but
Okay.
I feel like that would use loops. You'd have to look through
Mhm.
the second box after you count each of the items in the first one
Mhm.
to put it into another array.
Yeah. We don't want to use loops here. Yeah. Mm-hmm. So how can we use that function? Mm-hmm. So of our input array. Okay, let's just say let's call this a more descriptive unique values. And then let's return this. Okay, what we got was 2, 5, 8, 9, and 10. So that's the first part of this array. Great job. So we got the first part. Anyone have any ideas from here without using for loops? Maybe looking into the function we used.
Just to return like the count of each. I think for the unique function, there's like an extra parameter you can add and return.
Yes, yes, exactly. Turn counts equal to true. Okay, so let's quickly actually look at the documentation for np.unique. And I've clearly looked this up before. So np.unique takes in an array, and then it can take in other parameters, but you don't have to input them. So when we just pass in an array, it'll return the array with only the unique elements in it, which was the first part of our the problem. If you did return index equal to true, it would output return the indices that result in the unique array. So the indices of the unique elements. Then if we did return inverse equal to true, it returns the indices. It's just some other stuff. But what was useful for us was return counts. If it's true, it returns the number of times each unique item appears. And then access, if it was a multi-dimensional array, we would have to specify an access, which is really important for your homework this week.
So if it returns the number of times each unique item appears, wouldn't that just put a bunch of one? Because they're all unique.
Each unique item appears in array, in the past an array. So not in the sort, and not in the unique array that they get output.
Is that including the number, is the new array include the numbers that are repeated just only once?
Yes.
Okay, got it.
So if we scroll down, there is an example. So they call the function onto this array, and it outputs all the unique elements. So it's 1, 2, and 3. So that's what it outputs. And let's see if they have the return. Yeah. So over here, we have an array here, and they call unique on it, and they set return counts equal to true. And notice that they set 2 variables equal to this. It's because its output is a tuple, which is the format that I specified here. I should actually change this. Vowels and then counts. So that's what it outputs a tuple. So the first part of the tuple is the array with the unique elements, and then the second part is the array with the counts for each element. So if we go back here, its values were 1, 2, 3, 4, 6, and then the number of times they all appeared was 1, 3, and 1. So the documentation extremely helpful because they do show you how the parameters work for the most part. If there are a lot of parameters, they might not include all of them. For a lot of the homework, I would say has a lot of questions where you have to look at the documentation. Bless you. Yeah, so if we run this, yeah, we got our expected output. And then if you weren't sure what to search up for this question, I would have searched up how to find the unique elements in an array, Python, Numpy. And it tells you right here, Numpy is a unique function. And then if you look down here, it has the documentation for the function. And then if you look through it all the way, you could have seen this thing. I highly recommend when you're starting out to just look at the examples because they will make the most sense to you. And then as you get used to Python, you can take a look at the syntax and stuff. Are there any questions on this problem before we move on to the next one, which might be the last problem for today?
So how are you able to have two different variables set to for the equal sign? You have the val comma count. That two variables?
Yeah, so this function, it outputs as tuple. So when you set two variables equal to a tuple, it will set the first value of the tuple to the first variable and the second value to the second variable. And it's the same thing applies if it's like multiple, or there's more than two values in a tuple. If it were like 3, you could do x, y, z is equal to that tuple, and x would be the first value, y would be the second, z would be the third. Yeah. What was that?
What would happen if you set it to false?
If I set this to false, it would only output the unique elements in the array.
Oh.
It would not output the counts as well.
It's built into the documentation for NPM.
Yes. It is by default false, which if you notice here, it says this is equal to false, and that means that's the value by default. So even if you don't pass anything in, it will consider that these are false, or the input, the default values listed here. Do you have a question?
Yeah, can you go back to the other? So when you have two, because this is creating two variables? No.
Yes.
Yeah, so if you called one of them, then that would work. It
Yes.
just- Even if it doesn't reference the other, they're called in two different places.
Yes.
Because it's just setting the two images.
Yes.
Okay,
Because now they're separate values.
okay. Cool.
Are there any other questions before we move on? Yeah.
Could you use a function like this to create two different types of variables, like a string and a number or something?
It depends on what each parameter is supposed to output.
Okay, but it would. You could do that in like a scenario. Okay.
Yes. Okay, let's move on to this one. So you have a multi-dimensional array, and you need to find the mean along the columns, and then replace each value that is less than the mean with the mean of the column. So there's a lot to unpack here. I actually, let's start with the doc test. So I made an array, and it's this array. And when we pass it into the function, it changed a lot of these to 39. So I'm gonna go out on a limb and assume that 39 is the mean, and that these numbers are not 39. Oh, okay. We want to find the mean along the columns and then replace each value in the column if it's less than the mean of the column. So if you notice here, these two change to 18, which should be the mean of this column. These three change to 39. And then this one changed to 28. No, this is kind of a difficult question. You actually do need to use a for loop in here. I could not, for the life of me, find a way to do this without a for loop. So, but if you happen to find a way to do it without one, that's like awesome. So I want you guys to try this and like work with the people next to you to figure out how to do this problem because it is quite difficult, to say the least. Mhm.
Because I like whenever that's when rides like fun and end up with movement and that I would probably stall. So we're not like something is that or nothing. And then it's like I didn't stall. Yeah, it's like yeah. It's done and then it's like I don't install. I just think it's like yeah. Here, so transfer. But if I was sure it's still if you were like if you were so since you flew here if you have it's not gonna be so you have to Oh, I see, this one, so, but if I add CD to this. it would pull it to that. Okay, that makes sense, thank you. So. Thank you. It's not a.
Is that?
It's like for. It is a type, but it's very like specific. It's not. Something, I mean, it has to. Because usually our name is. But we have. Doesn't make it. What happened when people got all about it in primary school? You guys started
So, I think maybe some. They should be on. Those in why. All of that. That. And then the value. So. I'm just looking at the road, coming up home. Oh.
So.
Oh.
Whereas that means small, like every row, and then. What would your index for the? Oh, what? What would you always? You just stop. Yes. You would read. Everything after the column. That's what that's like. And every row, I think, so that first bracket represents the rows, and the second bracket the rows. You want to do that in the yeah, so if you don't do that, then it's saying everything before row but it is here, so we have now we want to use all the rows, but I
Oh.
Because you only put ink around the length of the array. The length of the array is only different. So you need to put the ink around the square root of the length. Because the square root is what comes in. Parentheses are x. It looks like you have this one. So this is being integer. It's just really like. Oh, so I don't read it. Oh,
No, I definitely do not.
in here.
I should, I thought it was.
But it's.
I just like it, getting too much shock.
It's being- See, the problem is you need to track your. Like array, right? Then you have that one shot. And then you have. Wait, because that one is with that. Oh, that one is with that. That one.
Oh,
Yeah, that's why I'm saying that.
Please.
They're not.
Please don't like it, there you go.
Thank you.
Oh.
Yeah.
Okay, guys, class is actually over. I thought I'd have time to go over this, so please look at the solution. Because this question introduces a lot of important concepts.
But, that's, I just, I was just.
Oh, let me also escape.